Hello, college algebra. So today we're going to just try to transform one of these exponential graphs. A couple things we're going to look at is first we're going to see that this function is exponential because the input, the x, the argument, is in the exponent, right? So we know it's an exponential function. So first thing, know your parent function. Which also includes what kind of exponential function. Well, the base here is e, which is 2.71 blah, 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 but definitely more than 1. So we have a growth function. And we know a couple other things. When we mess with the argument, we do a horizontal transformation. That's always the exact opposite of what I see. When I mess with the end of the function, I always get a vertical transformation. That's exactly what I see. And then this constant in the front, well, we know if it's negative, it's going to flip the end behavior. So all these things are still going to happen. So let's just show you how I would sketch this graph by hand. Okay. So first thing is I want to know my parent function. All right. So the parent function here is e to the x. Okay. E to the x. Things that we need to know about the parent function. Well, it goes through this point 0, 1. Goes through this point 0, 1. It is a growth function, so it starts slow and then it speeds up, right? Goes to infinity here, shoots off towards the asymptote here, and that's what our function looks like, right? Okay, so first step, know your parent function. So that's this graph right here. Then from there, what I recommend when you're dealing with exponential graphs is I like to deal with this growth constant next, okay? So the thing about the growth is this growth constant here, it's going to apply right after you get an output, right? So just like this one. So if I put in 0, I get 1. So if I put in 0, I get 1, and then I times it by -2. So what that means is that there's this point down here now at -2, and I still flip the end behaviors. So this guy doesn't really get flipped because it's still heading towards the asymptote. This is the end behavior that gets flipped. So now instead of shooting to infinity, it wants to go to negative infinity. Okay. So now what I've dealt with is the growth constant of that function, and that's helpful. So then from there, what I like, notice that I didn't move the asymptote, right? Okay, and then from there, what I like to do is remember that y is weird with these graphs. So we're going to focus on the y next. So this y, or this vertical transformation of +4, will move everything up 4. So remember, this point right here is at 0, -2 now. So when it moves up 4, it's now at 0, 2, right here. And then, but this, remember, this y equals is a y. This asymptote here is a y equals line. So it also gets moved up to here. So this is going to be y equals 0 plus 4 is 4. Okay. Don't change the end behavior. It's still a growth function. It starts slow, grows fast, and then there we are. So this is after I've done the constant, I've applied the kind of function it is, and now I've dealt with the vertical transformation. And then finally, the last piece here is to move the x's. So the cool thing is there's only one x I need to move, and it's the critical point here, and I'm doing it the exact opposite of what I see. So 0 plus 2 is 2. It was already at 2 at the y, so now my critical point's there. The asymptote does not move, right? The asymptote does not move. I still have a growth function, right? It still approaches the asymptote on this side, okay? So this is my complete function here. So then from there, all we got to do is call domain and range. Well, the domain is everything, right? So the domain is everything. The range is from -infinity, but then it stops here at 4, and the